to get us started. We're here in week 4, the end of week 4, so we're going to take a quick look at inverse functions and the difference quotient this morning to kind of get you started on sort of the techniques for that, for doing those processes. A couple updates. I did update synced the grade books between rational reasoning and Canvas this morning. There's a few of you, I think I got at least three of you that I brought over that were in the wrong section. We got you over, but I found that when you do that, you lose all your work. A couple of you sent me your screenshots, so I will get those updated. So if that's one of you, and again, I'm recording, so I'm speaking to 130 people right now, even though there's 10 in the classroom, but so just there will be some updates. So if you see all zeros and you've been working on it, know that I will get those updated. But I just wanted to give an overall. And again, those updates are just the current progress. So a 0 is not that, oh, I can't do it anymore, or it won't ever get updated. They will always get updated all the way to the end, because if there's something you missed out here and you keep going forward, by the end of the course, if you come back to it, it'll be helpful to get you doing well on the final. And you do it, I will get you full credit for it. Okay, so that's my policies. Doesn't matter. There's really no late time to learn something. If you learn it, you've learned it, right? I guess the end of the class, I have to issue a grade, but that's sort of that's the end point to it. But up until that point, as long as you learn it, at some point, there don't need to be any penalties. Doesn't take extra time. Now, I guess in the old days, when they were manually reviewed and stuff, maybe that was to save the teacher's time, but that doesn't occur. I don't computer grades them, right? So we'll just keep moving forward. So here we are. And then what we will do on next Tuesday, is it'll be a full review day. So I'm going to highlight what's in the review section. There's a review test, exam review. It was 50 questions. I'm going to show you it's been up to like 58 questions. I'll show you the new stuff that's there. Again, go through as much as you can. I'll sort of highlight ones that I feel we should look over for this in advance, but if over this next weekend you can take a good look at this, maybe start into it, that would be good. So let's see, where do we want to go? We want to go back to here. So the first exam content really is all that's available to you right now, and which at least here. Exam 1 prep, I did update that because they did update the practice test, but I didn't update this from fall because the first 50 questions are the same. All I did is put the additional review questions here. So this part is new. Let me just give you a quick, we showed it in the other class, but the old one's about 50 questions. There is an answer key, and again, in the answer key, sometimes it just gives the answer for you to check. Other times it actually gives some explanation. So there's some fairly deep explanations in the answer key. So do take a look at that. Down here, we'll get into this. So this time they're doing some skill-based sort of arithmetic. So notice this is just, there's not even any variables here. So, which is equivalent to that? So it's on simplifying exponential stuff. And you'll see that's what most of these are, is just algebraic skill things. And that's because, a couple of solves expand, but it's all algebra, no real word problems. Because they found in those that go on to calculus, some of the biggest problems they have is working with the algebra. So this is more the skill-based thing. So that's there to review, which means they will have some of these types of questions could be on the test. They're rewriting it this weekend. They're supposed to have it done so that we can get it to the printers and everything. The other thing I wanted to show you is inside rational reasoning. There's another place to kind of review those skill set things. I mentioned it early on. They don't factor into the grade, so you could say, well, then I don't really need to do them, but they're there for practice. And I forget what they're called, but we'll get there. So if you go, and again, the way I sort of navigate is not using the calendar, but just going off of the home page. And notice we've got these modules are listed. It's the skills practice 1. So it's for the first test. It's like 50 questions in itself or something like that. There's a lot of them, but they have multiple choice, so they are kind of, good. And that clicked. I don't know if that's right or not, but so you can kind of go through them. Um, oh, yeah, and multiple parts to things, and let's just leave that. So yeah, down here you can see 40 questions, 80 points. Work through them. I would work maybe every third one, just to kind of get an overview of what's there, what you're comfortable with. If you're comfortable with a particular thing and this just feels like busy work, I know what I'm doing, skip it. Uh, but if it's something that's kind of, I need a little practice on it, practice it. Okay, so that's what that's there for. It's a resource. And again, it will help you on the skills-based side when you get to calculus, because that's one of the things that the hardest part of calculus is not calculus, it's the algebra or the trigonometry, which we're going to get to later on. So that's why we build a good foundation here. Okay, so that's there. And then we're going to go with section 3.6 and 3.7 today. So I wanted to just highlight not necessarily how to work the homework, which is sometimes understanding what they're asking, but I want to just, let's see, where do I want to go? I want to show a sort of an overview of what the process is. Okay, so let's pull up a note sheet. And then again, over the weekend, maybe as early as Monday, I will also look over the practice tests. I'll post a few solution videos so that on the ones that I think people might be struggling with the most. And again, you've got those videos. Again, I recommend maybe starting with the problem, but sometimes if you don't know where to start, maybe watch the video, set it aside, and then come back later. Because if you're like me, I could see a problem worked even with the same numbers, and I could come back an hour later, and it's like a new problem to me, even though I saw it worked out. If it's not a new problem to me, it means it probably stuck in my mind pretty good. So some of this is just practice and remembering the skills. So it's okay to watch, again, if you're sort of stuck on things, just watch those solution videos, and maybe that gets you into the groove. Okay. So let's talk about inverse functions first. Get my So what is an inverse? If you had your clothes on, if you put your clothes on inverse, what does that mean? Yeah, they're inside out. Yeah, I've done that with, especially with t-shirts. You just throw the t-shirt. Oops, it's inside out. So inverse is the reverse. It's backwards. And that's really, in math, that's what we're talking about, an inverse function. We have an x and a y. All the inverse function is, it switches the x and the y. It makes them, the ordered pair is now backwards, sort of, but it's a function. If I add, what would be it's the other way to think of it, it's also the reverse in a sense. So if I add, what would be the inverse of adding? Subtracting. So adding is giving to something, subtracting is taking away. Those are inverses. If I multiply, what's the inverse of multiplication? Division. So multiplying is making many, dividing is putting them into groups. Okay, so those two are inverses. As we go on a little bit later, we'll see that exponentials have an inverse called a logarithm, and they'll work very similarly, but they they undo each other. So I'm working on the computer. I delete my paper. Fortunately, now most computers have an inverse function for delete. And what is that? Usually called undelete. Okay, so that's, yeah. Used to be, I remember in the early days of computers, if you deleted something, it was just gone. And you go, oh, geez, I just worked for 2 hours and now I got nothing because I hit the wrong button. But now we can undelete. Sometimes. Sometimes we lose, I've lost weeks of work sometimes when a disk goes out or something. So inverse function. So what you're going to be faced with is you'll be given a function, maybe like f of x equals 3x plus 4. And they'll ask you to find the inverse function. Well, what we do is we take this fact that an inverse really sort of switches things, it undoes things. And so in a function, x goes in and y comes out. So what's the inverse of that? Y goes in, x comes out. So it's kind of going in the outdoors type thing. So what we do with this is, one technique I've used is I change this function notation of f of x. What really is it? It's y. So that's sort of a first step. The next one I do, and if you look through the book, they do the same sort of thing, but they do it in a little different order. This is the way I like to do it. To actually get the inverse, just make the y an x and the x a y. That's all we got to do. So I change the y to an x, and I change the x to a y. In a sense, this is the inverse, right? Because I've done it. But what we want to write it now as an inverse function is we want to solve it for y, so we have y equals, so it's kind of in function notation, okay? And so we solve it for y. What does that mean? Get y by itself. So how would we go about doing that? Getting y by itself. We do inverse, right? So instead of adding 4, we're going to subtract 4. And we do it in the reverse order, right? Because order of operations says you multiply, then you add. When we're solving, we do the reverse. We take care of the addition part first by doing the inverse. Then we're going to take care of the multiplication part by doing division. Okay. So that gives us x minus 4 equals 3y. So we're getting closer. Y is now almost by itself. What would the next thing be? Divide by 3. Divide the whole thing by 3. And that's really our inverse function, right? And I'm going to bring the y over because we usually write it this way. Y equals x minus 4 over 3. We can just leave it like that. And then using function notation, we have a special notation for the inverse function. We show that it's connected to f by calling this f inverse. It looks like f to the minus 1 power, but that's not what it is. It's the way we're writing it. It's f inverse. Okay. Sometimes math we use things that look like they should be. And again, it's function notation. So now it's f inverse of x is equal to this. And what you see here, if you compare the two, in this one we are multiplying and then adding. In the inverse, we're subtracting and then dividing. So we're doing the opposite things in the opposite order. And so you can kind of start seeing it. That's what an inverse is. Okay, I dig a hole. What's my inverse? I fill it back up. So I drive to school. The inverse, I drive back home. Okay. So that's the idea. Okay, so that, and again, they'll have some activities. It's maybe a little bit more, but that's the technique to getting an inverse function. The cool thing about an inverse function, and this might be a little bit ahead where they go, but if you do a composition of a function with its inverse, what do you think happens? You dig a hole and then you fill it up. Now, in reality, you get a little mound. You can't get unless you stamp it down. But the idea would be is you get back to where you started, right? So this is a function with a composition. The inverse is getting plugged in. So you undid it and then you redid it. Where did we start where does every function start? With the input. So if you do an inverse and then a function, you're going to get back to where you started, x. Okay, because you added 4 and then you subtracted 4. Oh, we're still at x. And if you do it the other way, if you do the inverse of the regular function, I don't know why I call it regular, the forward function, you also get back to x, whatever, because it's doing something, undoing it. You get back to wherever you started. Okay, so that's kind of an interesting aspect of inverses. But when we think of it, I take x and I add 4 to it, and then I subtract 4 to it, I'm right back to x, right? Take x, I multiply it by 3, and then divide it by 3, I'm right back at x. That's the idea. Okay, so we okay with that part? Okay, get you started, get you working. The other part is something called a difference equation, difference formula. Difference equation, I guess we'll call it. I'm going to give you another name for this. This is really just slope. The slope formula. And I'm going to, it doesn't look like it because I'll give it to you just as it does in the text, but I'm going to compare it to the slope formula and I'm going to get you to see it's really just the slope formula. So they give you this difference equation as something like this. F of x plus h minus f of x all over h. Okay. What's the slope formula? y2 minus y1 over x2 minus x1. Okay, and I'm going to show you that difference formula, that's really all it is, but with different, like a different language being written in, which is function notation. Okay, so what they've done is over here, the 2 points are going to be, let's do it this way, x1, y1, x2, y2. So they're going to take those and in this case, x1 is actually just x, and y1 is written as f of x, right? When we use that function notation, f of x, that's actually the y variable. It's just a different way of writing y. So up here, we see f of x, it's actually just y1. Well, if that's the case, what is x2 and y2? Well, x2, as you can kind of see the input here, is actually x plus h. So it's wherever x is and we add something to it. We could add 2, we could add 3. The reason we call it h is we're going to let that, this is setting you up for calculus. In calculus, what you do is you let h become very, very close to 0. So if you're at x and you add a very little bit amount, where are you? You're still in x's neighborhood. You're almost there. If you add 0 to x, you're actually at x. What that's going to allow us to do when we get into calculus and get some other tools, it's going to allow us to find the slope not at 2 points, but at 1 point. But we use this technique of saying, well, we sort of have 2 points, but we just let them become 1 point, and as we get them close, we actually get the slope of a point. Okay, so that's where we're going, but not this semester, down the road. Okay, but it still doesn't, it might not feel like the slope formula yet. So what would the y value be? Well, it's f of this plugged in. Okay. And so you now kind of see the connection up here in this formula. So what this formula really is, this is, let me change colors here. This is really y2, and this is really y1. Well, what happened to x2 and x1? Well, notice if I take x2 and I subtract x1 from it, what do I get? X minus x is 0. I just get h. So this h is actually 2 points. It's x plus h, and it's x. So they're at some point in time there was this x plus h and there was this minus x, but they simplified it. But in the simplified version, you don't see this as y2 minus y1, x2 minus x2. You don't see it as a slope formula. So I want you to, maybe you write it a few times and then simplify it. But just remember, these missing parts is what can cause a lot of confusion, because you see it, oh, this is a special formula. Well, it's just a slope formula. Okay. And what we're going to do is this, again, we're just getting you to practice. So I'll go through one of these because we won't get too complicated initially. We'll be given a function, f of x. Let's go with this 3x plus 4 that we had before, linear equation. And they'll ask us to use the difference formula on this. Okay, so what do? Well, the difference formula, f of x plus h minus f of x all over h. And remember that h actually had a x plus and a minus, so that's already been taken care of. So what I like to do is over on the side, what is f of x plus h? Well, really, that's just this function with, remember I showed this, I think, Tuesday with composition. This is 3x plus 4. So when we've got something inside to plug in, we got some space. Let's put that like this. Okay, so that's a kind of a composition, right? Or there's something in there. So what is f of x plus h? We'll go ahead and simplify this a little bit, so we have to distribute the 3. It's really 3x plus 3h plus 4. Okay, what's f of x? Well, we've got it right here. Don't really need to rewrite it. But watch what happens when we put it into this formula. So now I've got this part at the front. And I'm going to subtract. Now this is where a lot of errors can creep in, because you think, oh, just subtract 3x plus 4, so you put minus 3x plus 4. But remember, we're subtracting the whole thing. So what is 4 going to become? It's going to become minus 4. We have to distribute. So forgetting to distribute is the biggest problem. And it's like a little thing, because, I just didn't get the negative on the 4. But it makes a big difference. Okay, so then, and this is still all over h. Okay, so this is the difference formula so far, f of x plus h minus f of x, but now it's got the function in there. I'm going to distribute this, and just to save myself some time, since I've got a different color, I'll put negatives here. So I've got a plus 3x and a minus 3x. What's going to happen when I combine those? Canceled, they're 0. So that goes and that goes. Plus 4 and minus 4, gone, canceled, 0. And that's what you're going to find when you do this. So if things aren't canceling out, check your distribution. Maybe you forgot to put, because that's the whole goal of this. The function will kind of basically cancel out. What's left in the top, 3h is all that's left. So what we're ending up with is 3h in the top, h in the bottom. What is h divided by h? It cancels, it becomes 1, right? And what is 3 times 1? 3. So that's the kind of thing you're going to be looking for. I think someone sent me, I think they were left with something like this, but when you do all of this part, you should, if it's linear, you end up with just a number. Okay, cool. You can do this with x squared. It gets a little more complicated. I don't think we're going to be facing anything like that, so I don't want, but with linears, it's not too bad. This gets harder if you do an x squared, because then you have to FOIL it out. It just gets messy, okay? When you get to calculus, you'll see you'll do it at like the first couple weeks usually, but then you learn some shortcut rules. But this is what they're going to do, is eventually let h go to 0. And again, if in this very beginning part, can we let h become 0 without bad things happening? Well, what happens when we divide by 0? what does your calculator tell you whenever you try to divide by 0? Is that? It doesn't like it, right? It'll say error. Please give me something I can do. Yeah. Technically, division by 0 is infinity, but a calculator will say it's undefined, right, in mathematics. So we can't make h be 0 here, but we can do a bunch of algebra to get it to cancel out, and then we're okay. Okay, so that's a whole goal here. So you're going to have in today's lessons, and again, you're all at different places, but 3.6 inverse functions. So we're switching the x and the y, solving for y. 3.7 difference quotient, which is really just a slope formula, but it's a little funky to work through. But hopefully by this time you're getting used to having more than just a number to plug in for x, and sometimes you're plugging an x in for x, right? So that's my technique, is change x to a big open parentheses, then you've got a space just to put whatever inside the parentheses. It's a lot easier. Your mind's not going to be fighting, wait, how can I put x plus h in for x? That doesn't seem right, and really at that place, x is just marking a spot where something new will go. And so, yeah. So do that, make the open space and then plug the stuff into the open space. And I think once you get doing that, you might be able to take some shortcuts. But until it's like second nature, kind of keep doing that. All right. Questions about anything? So when's our test? Next Thursday. So we want to get ready for that. We have our reviews ready. What are we doing next Tuesday? We're going over the review. We'll do some in class if you've got questions. If you don't, we'll just go to work session and we'll do them individually, or in groups, however you want to do it. I will post some solutions on the maybe more. I can't do 50 myself. I mean, it takes time, but I'll do a few of them that I know that are a little bit more challenging. If you've got some over the weekend that you would like to see, send me an email, and I could post them to my YouTube page, and then I'll in the exam review page where I'll put them, and I'll send out an announcement when I do it. I'll put them actually here. I'll start putting the links to the videos below here, and I'll say question number 15 solution. Boom. You could click on it, you'll be taken to the video. Might even put just a little video there, but they'll be in this exam one preparation. Okay. And I might have some from last semester. I can't remember, but I'll locate them. Whatever I have from last semester, I'll do it. That saves me some time if they're there, and then I can do some other ones. So if that's all we've got, I'm going to stop the recording.